Hello, this is Mr. Collier, and today we're looking at increasing and decreasing functions. So if we look at this function here, it's obvious to see that it's increasing on this interval and this interval here where the y values are getting smaller and smaller and smaller and smaller. So it's decreasing here. So it's decreasing when x is less than 3 and increasing when x is greater than 3. And if you look at exactly at x equals 3, then we have what we call a stationary point. It's not increasing or decreasing. Okay? And this is related to calculus because if you look at the slopes of the tangent line, you can have positive slopes here on the increasing section. Oops, that's actually positive, not the number. Okay, so the slope of the tangent lines are always going to be positive here. And if you look over here, if you look at a tangent line here, slope is going to be negative. Or here, slope is going to be negative. And here, at the stationary point, you have slope equals 0. Okay, so if you get the derivative and it's positive, you know that the function is increasing there. You get a negative derivative, it'll be decreasing, and if you get the derivative to be 0, then you have what we call a stationary point. So here, if you look at this question, look at this graph, we have two stationary points. Okay, we have at x equals 0, it's a stationary point, and at x equals 3.33, we have a stationary point. Okay, so the derivative is 0 at both of those points, so we have, at the stationary points, we have the derivative is 0, the derivative is 0. Okay, now this is an increasing section right here. So here you're going to have the derivative is greater than 0. Here's another increasing portion. The derivative is greater than 0. And for this section, kind of messy, derivative is less than 0. Okay, so this is the decreasing section of the function, right? So we have it's increasing when the derivative is greater than 0, decreasing when the derivative is less than 0, and when the derivative is 0, we have stationary points. Okay, if you look at this graph, we're going to have 3 stationary points where the slope of the tangent is equal to 0. Now this one's a little bit different, but still we have 2 points where the 2 stationary points at x equals 3, and we also have a stationary point here at x equals 0. Okay, these are both stationary points. As we can see right here, this is a local maximum, and I'm going to write it down. It's a local maximum, as we discussed before. This one's neither a maximum or a minimum, so it's called an inflection point. And we'll talk about that a little bit more later. Okay, so those are the points where the derivative is 0. So here's this kind of sums it up. If the derivative is greater than 0, it's increasing. If it's less than 0, it's decreasing. If it's equal to 0, it's a stationary point. It's not increasing or decreasing. So if we look at this graph, for which points in the curve is the function increasing, decreasing, or stationary? So stationary is pretty easy first. It's stationary at A and D. Those are the points at which the slope of the tangent is 0, the derivative is 0 at those points. So it's decreasing from A all the way down to D, so it's decreasing at point E, and it's increasing here and increasing here, so at B and C it's increasing. Alright, so we can actually do that for any function. The easiest thing to do here is to draw the graph of this function. So I'm going to do that on the calculator. I've already typed in the graph, and here's a important tip for graphing. If you press zoom 0, which is zoom fit, it usually shows you all the relevant points that you need. So here we see that we have 2 stationary points. Now to get those points exactly, we could find the derivative and find out where the derivative equals 0. But we can also use the feature on your calculator to find the local minimum and local maximum. So if I want to get this one right here, actually let me sketch the graph first. Okay, it kind of looks like that. Let me just redo that a little bit better. Okay, so I've got the sketch of the graph. I'm going to try and draw the axes here. So the axes is going to happen just before this hump, this local minimum here. Okay, something like that. Alright, so we've got 2 points, 2 stationary points at here and here. We have to find those points on the calculator. We're going to find a local minimum or local maximum here first. Okay, right there. So I'm going to go second function, trace, which is the calc feature, and go to maximum 4. So left bound, I just have to make sure I go to the left. It's very hard to see here. Once I did zoom fit, actually let me change the window a bit so I can see a little bit further down. Right now y min is at negative 60. I'm going to set it at negative 30. And I'm going to graph that again. Okay, now I can see it a bit better. So second function, calc, and do 4 for the maximum. Okay, let me try that. Okay, so I'm at the left of the maximum. I'm going to press enter. Go to the right of that maximum, press enter, guess, I'll go right onto it, press enter. So you get 6 or negative 6. So at x equals negative 6, we have a stationary point. Okay, now it says points in here, but I think we're just looking for the x values for now. Alright, and now we're going to look for this one here, which is the minimum. Now I can't see the minimum that well, so I'm going to go back to window again. I'm going to change that to even maybe negative 100 so I can have a clear picture of everything. It's a bit better. Okay, I'm going to find that local minimum. Press 3. Okay, I am to the left of it. Now I'm going to go to the right of that minimum. And I'm going to guess, I'm going to go right onto it. Press enter, I get 2. So x equals 2 is the other stationary point. Okay, so where is it decreasing? Well, it's decreasing. Let's look at where it's increasing first of all. It's increasing from, I guess, from negative infinity all the way up to negative 6 is increasing, right? So if x is less than negative 6, it's increasing. This whole section is s is less than negative 6. It's also increasing here at x is greater than 2. Alright, and it's decreasing. It's decreasing right here in between negative 6 and 2. So we can write that as x, actually we write like this, it's between negative 6. X is between negative 6 and 2. So x is greater than negative 6 and less than 2. So that shows you the interval at which the function is decreasing.